Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. Okay, so this is question 3770. It's called largest prime from consecutive prime sum. Okay, so we're given this integer n, and we want to return the largest prime number less than or equal to n that can be expressed as a sum of one or more consecutive prime numbers starting from 2. If no number exists, return 0. So starting from 2 already tells you if n is less than 2, we can just return 0 because if there's no number existing. And then if you look at this case, if n is 2, then we can just return n. Okay, now we can actually get all the prime factors of n using the sieve algorithm. So let's do that. So if it's less than or equal to 2, return true. Otherwise, for j in range 2 to int num to the power of 0.5 plus 1. So this is the sieve algorithm. I covered it in my last video. So if a of j is true, then for k in range, j times j to num with a step size of j, a of k is false. So that saves a bit of time complexity there, and then at the end we can just return true. Okay, cool. So now if we go through a, so if a of I is true, then we can get all the primes, right? So the primes would be I itself, right? Okay, cool. So now if we print primes, okay, so a is supposed to be defined as true times n, and then we set 0 and 1 to false in accordance with this. Cool. So we have all our primes here, and then we can just go through the primes and basically say if SS is in good or is in primes, then we're going to maximize because we're trying to find the largest prime of SS, and SS is less than or equal to n. And then at the end, we can just return our answer, right? So finding the largest consecutive prime. And then here we have an interesting case where if is prime of n, then we can just return n and define our own is prime function. So for j in range from num from 2 to int num to the 0.5 plus 1. So if num of j, or if num modulo j is equal to 0, then we can return false, right? Otherwise, we return true. So that's another way to find if a number is prime. And then here, something's interesting because we didn't include n itself. So basically, we can just... so if n is in good, because those are the prime factors, or is in primes, then we can return n, right? Okay, so let's just go ahead and call this S is set of primes and is in S. Let's submit this for now. Okay, so let's actually accumulate these primes, and let's call this, because we want a consecutive part that is summing up to it. So if SS is in PP maybe, okay, and so, or if it's in the original primes, and then if n is in PP, then we can return n. And there you go. So that after you play around with it a little bit and use the sieve algorithm, that's what you get. And get rid of the print statements. And there you go. passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.